Hello, we're Team Dot from Russia St. Petersburg, and it is our application for Virtual Robocop Asia Pacific.
Because of COVID, we didn't have enough time to release all new features.
Whatever, right now, we are glad to present you our new robots. At first glance, our new robots look exactly like all other. But this time we made several significant improvements that really differ our new construction. First of all, this year we began to use Maxon brushless motors instead of brushed Pololu. And to use them properly, I made special OmniWheels modules. Each of these modules consists of bearing hub, built-in gearbox with a gear ratio 3:1, OmniWheel itself, motor mount and motor. Such construction minimizes all radial loads on the motor shaft, and also it allowed us to make all wheels exactly the size that we need to. Another one great feature of our 2020 robot design are two dribbles placed on opposite sides of the robot. We decided to use two of them to spend less time approaching ball from every angle. My dribble design uses two separated trolleys. I found that this configuration works better on higher angular velocities. To kick ball from both dribblers, our robot used advanced kicker system. I made it in such a way that robot can kick ball in 3 different directions from each dribbler using only 2 solenoids. As well, we put lots of useful electronics and various sensors in our robot. For example, here we have one board computer HEADSWIM 3, brain of our robot. Or here is LiDAR sensor. We use it to clarify our own position on the field or to detect enemies' robots. But still, the hardest challenge for me was to put all required hardware into the body that would compile with 2021 rules. Thus, robot diameter is only 197 mm and its weight is under 2300 grams.
Electronics is a very important part of each robot, so there are 3 main and 7 additional self-developed boards in our new robots. The main boards group include the motherboard, the line sensor board, and the boost voltage regulator. The additional boards group include 4 ball sensors, the battery board, and 2 communication boards for camera and LiDAR sensor. In the developing stage of our new robot, we had faced some problems. At first, we began to use smaller solenoids than last year. To keep the kick force, it needed to charge the capacitors with a high voltage. To do this, I had to develop a boost voltage regulator that would be able to charge capacitors up to 250 volts. Because of another problem, I made a new line sensors board. Our old robots often went out because they didn't see the line well. I solved this problem by changing the line sensors to other with bigger viewing angle. Furthermore, I placed them in the form of a cycle instead of a cross. Now, our robots always see the line perfectly. From the last year, our team has made a really good progress in electronic development. Electronic part of our new robots is most technologically advanced and reliable of all that we have ever made.
В наших роботах кодовая база разделена на 2 части. Низкоуровневая на микроконтроллере STEM, которая осуществляет управление моторами, и высокоуровневая на одноплатном микрокомпьютере VIM, который производит обработку видеопотока. С помощью камеры наши роботы определяют ворота и мяч по цвету, а затем позиционируют себя на поле. Также они способны определять положение роботов противника с использованием сверточной нейронной сети и лидара. Чтобы упростить отладку роботов, я написал кроссплатформенный терминал на базе Python 3. А сейчас мы вам покажем выполнение роботом базовых задач Лиги.
The striker goes after the ball, moving around, trying to hit ball in the center of the empty space of the goal. If the ball an out area, the robot moves along the outbound, aligning with the ball. The goalie aligns with the ball and drives to it when the ball is near. Because of high camera latency, goalie approximates the velocity of the ball and predicts its position in the future for a more accurate hit.